Hello guys, in this video we are going to see the solution for the Hyderabad Best Coder 2017 coding practice set question is anagrams. So the problem statement is we were given two strings that may or may not be of equal length. Determine the minimum number of character deletions required to make given two strings anagrams. Any number of characters can be deleted from the string, either of the string. So first of all, what is an anagram? We consider two strings to be anagrams of each other if the first string letters can be rearranged to form the second string. So both strings must contain the same exact letters in the same exact frequency. Let's take an example. So let's take an example such as ABC and CAB. ABC and CAB are anagrams to each other. All the characters which are present in the string ABC are also present in the string CAB, and also the character counts are also equal. A is occurred one time in ABC and A is occurred only one time in the string CAB, and this is same with the remaining characters. Let's one more example for anagrams are such as silent and listen. Now let's take two strings which are not anagrams, so which is suitable for our problem statement, such as ABC and CDE. ABC and CDE are not anagrams. So according to our problem statement, what should be the minimum number of character deletions required to make ABC and CDE anagrams? So one approach is delete A comma B from ABC, delete B comma E from CDE. Now after deleting A comma B from ABC, we are left with character C, and after deleting D comma E CDE, we are left with C in the second string. C and C are anagrams to each other. So the minimum number of character deletions are 4 to convert ABC to CDE. So let's see how we are going to do it programmatically. Now with the help of a counter array, and with the help of the ASCII values we are going to solve this problem. Let's take an integer counter array of size 26. So we are having 26 English alphabets, so we are taking the size of the counter array as 26, and you know that the ASCII value of small English letters ranges from 97 to 122. At the same time, the ASCII values of capital letters ranges from 65 to 90. So we are going to take the help of this tree. Now initially, all the values in the counter are initialized to 0. So 0 and so it is initialized to 0. Now let's take our sample input string ABC and CD. Let's take the first input string, that is first input string ABC. The first character in the input string ABC is A. So I have to store down the character counts in the counter array. So how I am going to do it? With the help of ASCII values, this becomes simpler. So ASCII values are used to map a character to an index in the counter array. So for every small character encounter in the input string, subtract small a from it. So if the input character is A, I am going to subtract A from it, which is equivalent to 97 minus 97, that is equals to 0. So at index 0, I am going to store the count of the character A. Now let's consider the input string B, input character B. Now I am going to subtract A of 97, that is equal to 98 minus 97, that is equals to 1. So at index 1, I am going to store the count of character B's. So, and this is same for all the characters from A to Z. So if I encounter any capital letter such as A, instead of subtracting small a, we are going to subtract capital A. So capital A minus capital A, that is equals to 65 minus 65, that is equals to 0. Now if I encounter something like capital Z, that is equals to character capital Z minus character capital A, that is equals to 90 minus 65, that is equals to 25. So at index 25, I am going to store the count of the character capital Z. Now our input string is ABC. So the first input character is A. So its index would be minus a, that is equals to 0. So at 0 index I am going to increment the count of the character A. So initially it is all zeros, now it is going to be 1 comma and all 0. Now the second input string is B, character is B, so B minus, that is equals to some 98 minus 97, that is equals to 1. So it index 1, increment the count. So previously it is 0, now it is going to become 1 and so on to 0. Now the last input character is C, so that is equals to minus, that is equals to 99 minus 97, that is equals to 2. So at index 2 we are going to increment the count, and 1 minus all followed by zeros. Now after processing the first input string, my counter is 1 comma 1 comma 1 and so on to the zeros. Now we have to process the second input string. The second input string is CDE. Now the first character in the CDE is C. So the ASCII value, the index obtained would be C minus A, that is equals to 99 minus 97, that is equals to 2. So for the second input string, instead of incrementing the count, we are going to decrementing the count. That is the logic here. So at index 2, instead of incrementing the count for the second input string, I am going to decrement the count. So it would be 1 comma 1 and 0 0 and so on, followed by zeros. Now so the array would become, so the next input character is D, so its index would be B minus A, is equals to 100 minus 97 is equals to 3. So index 3 I am going to decrement the count. So it would become 1 comma 1 comma 0 comma minus 1 and so on, followed by zeros. Now the last input character is E, so index obtained would be E minus A, that is equals to 101 minus 97, that is equals to 4. So at index 4 I am going to decrement the count, 1 comma 1 comma 0 comma minus 1 comma minus 1 comma 0 and followed by all zeros. Now after processing both the input string, my counter array become this is my counter array. So how to obtain the minimum number of character deletions from this counter array? So minimum number of char deletions is equals to sum of absolute values of all the character counts, sum of absolute values of all, sum of absolute values of all values in the count array. So let's bring this down. So all the values which are present in the count array are 1 plus 1 plus absolute value of minus 1 plus absolute value of minus 1, that is equals to 1 plus 1 plus 1 plus 1, that is equals to 4. Since absolute of a negative value returns to positive, so the minimum number of deletions required to make ABC and CD as anagrams is 4. Now let's take two strings which are anagrams and let's check out this further. So let it be ABC and CAB. Now after processing the first input string, the counter array would become like 1 comma 1 comma 1 and followed by zeros, all zeros. This is because capital A minus capital A, that is equals to index 0. So index 0 we are going to increment the count, so it became 1, and capital B ASCII value 66 and 66 minus 65, that is equals to 1. At index 1 we are going to increment the count. Capital C ASCII value 67, 67 minus capital A, that is equal, so 67 minus 65, so we are going to get index 2. So at index 2 we are going to increment the count. So after processing the first input string, my character array, my count array is like this. So for the second input string, consider CAB. So after processing the second input string, my count array would become 0, 0, 0 and followed by all zeros. This is because the same procedures we have followed for the above example. So now if you find out the sum, that is equal to sum of all zeros is 0, so it will become 0. So if you obtain a sum of 0, then one thing, so that is, if the sum is 0, then the two strings are already anagrams. There is no need for character deletions. If the sum is greater than 0, that sum value is the minimum number of character deletions. Now let's see how to code it. So here we are taking the first input string, we are dynamically allocating the memory, and the same for the second input string. We are taking the inputs from the, and also we are calling the function anagrams, which is main logic. So let's take an integer count array of size 26. So initially we are going to initialize it with all zeros. So let's take int I for indexing purpose. So for I is equals to 0, I less than 26, I plus plus, count of I is equals to 0. Now we have to process the first input string. So let's take another two indices. So some j, comma k. One is for first input string and another is for second input string. So for j is equals to 0, j not is equals to, so sorry, first of j not is equals to null character, and just, so what we are doing is we are processing the string character by character until a null character is encountered. So first we have to check out whether it is a capital letter or small letter. So if first of j and z greater than or equal to first of I, first of j. So what this condition means is that if the input character is in between a and small a and in between small a and small z, I am going to increment the count as like this, such as first of j minus. So if we encounter a small letter, we are going to subtract it with small a. Else if we are going to encounter, we are going to come across a capital letter, then instead of small letter we are going to do capital A. The logic is same. So for the second input string, instead of incrementing, we are going to increment the count. So the logic is same. So this is the second input string, second, and let us take it as some k plus second, k non equals 0 and k plus plus. If in between the small and small z, so for the second input string, instead of incrementing, we are going to decrement the count. So minus minus. So this should be the second. And this should be the second. So instead of incrementing the count, we decrement. Now we have processed both the input strings. Now just we have to find out the minimum number of character deletions. For that, so for I is equals to 0, I less than 26, we have to count, we have to sum up all the character counts, I plus plus. So let's take a variable which stores the character deletions. So del, let me initialize it with 0. So del plus is equals to absolute value of count of I. So if L is equals to 0, then just print 2 strings are already anagrams, else print the minimum number of character deletions required, that is equals to del. And so this is the code for finding out the minimum number of character deletions required to make 2 strings as anagrams. So thank you.